In this section, we discuss barriers. In particular, we start by discussing barrier model to better understand what barriers are and when they are useful for the development of our application. Then we will study how to implement barriers in Python, and we analyze a little use case to see barriers that work in a Python application. Barrier provides a very simple abstraction for use by a fixed number of threads that need to wait for each other. There are different use cases. A typical one is in application where processing can be divided in a sequence of stages. A thread that has finished its computation calls a primitive barrier and stop waiting for the others. When all the involved threads have terminated the computation of the stage and they have invoked the barrier, the system can unlock them all and move to the following stage, possibly the following barrier. Now, let's try to understand better how a barrier actually works. On the right-hand side of this slide, you see our representation of a barrier. Basically, we have a variable with the number of threads that we have to wait before we open the lock. So in the beginning, the lock is closed and we are waiting, in this example, for 2 threads. When we have 2 threads accessing the barrier, we can unlock this lock. So let's see how things work. In the beginning, the end thread is set to 2. Then now a thread approaches the barrier and acquires the barrier. So the end thread is decreased to 1. So it means that we are waiting for another thread before opening the lock. The lock is still closed. Then thread T1 approaches the barrier and access the barrier. So we decrease the barrier, the variable end thread, and now we can finally open the lock. After the second thread, the thread T1 has entered the barrier and the lock has been opened, both thread T0 and T1 can finally enter into the barrier. So we have been waiting for this, thread T0 has been waiting for another thread, namely thread T1, to join the barrier. When the second thread arrives to the barrier, we are finally enabled to enter into the section. We are finally able to be released, and the thread T0 that has been blocked is finally released and is moved to a runnable state. Another interesting use case for barrier to our experience is in the initial thread configuration. Basically, threads sometimes have kind of dependency, and some thread may assume the availability of peers that have not started yet. This may result in exception, error, issues. Sometimes you see code where you have a thread that is kind of sleeping for some time before actually starting its execution because it's waiting for other threads. Well, this is not a good way to organize your software, and barriers can help you in organizing your software, the setup of the threads that compose your application, so that you create a thread, you start a thread, and it's waiting for other thread, and when the thread that are necessary to run the application are all up and running, they can finally unlock the barrier, and we complete the setup stage, and we enter in operation stage, where threads do their job, their actual job, and they don't need to wait for any other thread. That's a possible use of barriers in actual software implementation. So consider barriers for the initial setup of thread when you need to wait for others. Now let's see how we can implement barrier in Python. As usual, our reference is the threading module. And in particular, within the threading module, we have the barrier class. The barrier class creates a barrier object for the specified number of parties, the specified number of threads we have to wait to be able to open the barrier. So we are waiting for the specified number of threads or parties before we can open the barrier. And important, we can also specify a callable, which is some code that is invoked by one of the threads when they are released. In this case, the callable can do something, probably notifies some other thread or write somewhere that a certain stage in computation has been completed. That's an important aspect that could simplify the implementation of complex synchronization logic, especially when we are dealing with multi-stage computation ruled by barriers. Finally, it is also possible to specify a timeout for the barrier. The most important method in the barrier class is indeed the wait method. When all the threads have called wait, they are all released simultaneously. Basically, when we enter into the barrier, we call wait, and we are waiting for others. When everyone reaches the barrier, we can enter, and we can pass the barrier. That's the idea. When we do so, well, when everyone has reached the barrier, every thread is released, and every thread is returned a value, an integer value, in the range 0 to parties -1, and each thread receives a different number. Why? Yeah, well, this could be useful for the implementation of some special housekeeping task for the thread. It can be useful in certain situations. Most of the time, it is not. So most of the time, you can simply ignore the value that the wait returns to you. This is what happens when we are in a normal state, so everything is fine with our barrier. But there are also situations when the barrier is put into a broken state, so we have had some issue with the barrier. The first case is when we have a timeout and the times out, so we exceed the timeout threshold. In this situation, well, the barrier is put into a broken state. Similarly, in the constructor is specified a callable that one thread is expected to call when all threads are released. Well, in this case, if we have some error, the barrier is put in a broken state. These are situations you don't want to have to deal with. So you have to manage them. You have to manage them, and you have to catch exception and manage the situation properly. Well, it's sometimes necessary to let me say, void a barrier, to reset it or to abort it in order to manage and to deal with special situation. So we have dedicated method to deal with this. In particular, we have reset and abort method. Let's start by analyzing reset. Basically, the reset method returns the barrier to its default empty state, and any thread that is waiting on the barrier receive a broken barrier error exception, and you have to deal with this exception. Similar situation for abort. Abort put the barrier into a broken state and causes all the threads that are waiting on the barrier to receive a broken barrier error exception that they have to manage, that they have to catch and manage. Let me stress that if you receive an exception like this and you don't catch the exception and you don't implement some type of logic that makes it possible for you to manage the exception, that thread terminates its execution. That's very important. It's one of the causes you may find very, let me say, errors that are very difficult to replicate, errors that occur only sometime, and you don't understand why some thread stopped working. Possibly this is the reason, an exception that was not caught properly. It's time to have our hands dirty by analyzing some actual code. So let's start with this simple example. Let's start by analyzing the main function. Basically, we create a barrier and we set up the number of threads that we have to wait in order to enter the barrier, in order to trespass the barrier. And we set this number of threads up to 4. Then we create and start 4 threads and the main waits for the determination of all 4 threads we created. So something very, very simple. Something very, very simple. But how do we actually use the barrier? Well, first thing, we have to import the barrier as usual. And important thing, we have to use the wait method. With the wait method, we expect the task to approach the barrier, attempt to trespass the barrier, but for sure it has to wait as long as the number of thread that is expected to join actually approaches the barrier. Only when we have, in our example, 4 threads attempting to trespass the barrier opens the gate and makes it possible for all the threads to proceed. Okay? Now let's have a look to the code of the task, and it's very, very simple. And in particular, we see that we have some random time. Then we print a message that thread is attempting to approach the barrier. Then we wait on the barrier. Once we are enabled to enter the barrier, the task prints, I've passed the barrier. As simple as that. But what is the the result that we expect, well, it's very simple. Basically, we create the threads. The threads print, I am approaching the barrier. Then the threads are waiting till the fourth thread approaches the barrier and they can enter. Exactly what we have seen in this execution. As usual, we run our execution through the command line, and what we see is very simple. We have thread 1, 3, 0 approaching the barrier. They wait until thread 2 approaches the barrier as well. Then all the thread all together pass the barrier, trespass the barrier, and can print their message. Thread 1 pass the barrier, thread 0 passes the barrier, and so forth. And they can terminate their execution. That's it. Now let's make an update to our application, and let's consider the following example. Basically, the code is almost the same as we have seen so far. So we still have a barrier of 4 threads. We have we create 4 threads, we start them, and we wait for their termination. And still we have our task, and our task still have a random time sleep, then prints message, waits on the barrier, and prints that it has passed the barrier. So everything seems quite similar to what we have done so far. However, there's a difference, and the difference is in the definition of the barrier. In particular, we pass in a lambda. A lambda is a function, basically, and that lambda, in our example, simply prints a message on the console. That's it. You could do everything here. And the important thing is, typically we write somewhere that the thread have passed this gate, this stage of execution. It's what we said before. In our example, we limit at printing a message on the screen. So let's see what happens now if we run this application, and let's try to understand when the lambda is run and what actually happens to in our application. Well, very simple. The output is not that different from what happened before. So we had thread 0, 3, 2, and 1 that approach the barrier. When thread 2 approaches the barrier, we have four threads that attempt to pass the barrier. So the gate opens, and this enables the thread to pass the barrier, but also triggers the function we passed in. So trigger the lambda function, and we print a message, thread passes the barrier. As simple as that. So the message is, you can use a barrier to synchronize the execution of threads in order to wait for a specified number of threads to approach the barrier, and move on only when all of them reach the barrier. In addition, you can also trigger a function that can do something for you when the the gate of the barrier open in order to let all the threads to pass. In this section, we discuss barriers. In particular, we discuss the barrier model. What is a barrier? How can we use it? And in addition, when we should use a barrier. Then we introduce the Python class for implementing a barrier. And we've seen barriers at work in a couple of simple examples. That's all.